What is CSR? Corporate social responsibility. So they have some social responsibility under CSR funding. They have tax exemptions. They have some benefits when they show some amount spent under CSR grant. So now if someone is buying a captive power producer is a producer who is generating power and is also consuming power. Okay, there are many industries which also generate power and they sell excess power to the grid, and they also have their machines running on that generated power. These kind of power producers are called as captive power producers, CPPs. A wind farm owner or a solar farm owner who are only generating, or any other power producer who are only generating power and selling it to the grid, okay, they are called as independent power producers or state owned power producers and such things. But captive power means they are generating power and some part they are consuming also. Only excess are being sold. So CPPs. Industries who are owning also can buy, and also there are this whatever they are procuring, they are getting benefit under CSR. So as a social responsibility, and individuals also. In India, at individual level, only industries are authorized to enter the energy market, but a normal agricultural customer, domestic customer, commercial customers are not there as of now. But other countries do have. So these are some key requirements for REC denomination. It's like one REC certificate, one REC credit point you get if you have a transaction of 1 megawatt hour. Validity is for so many days. The categories are solar REC or a non-solar REC. It has to be renewable energy, but is it solar or non-solar? And the transaction will happen only through the power exchange platforms, which is Indian Electricity Exchange, Power Exchange, or the latest one, Hindustan based. So these are the platforms, and the other things are already there. Okay, these would also get updated over time, but these are this is the CRC order dated 2014. After that also there would be some revisions. So we understand that renewable energy certificates are also traded. So whenever there is a trading happening, you have blockchain coming into picture, so that you have security and privacy of the trade data. Again, immutable, again it cannot be changed. All these things are there. Carbon emission and carbon credits and emission trading is also in line with this only. In this, you have this life cycle with an example with blockchain coming into picture. So these are all the people who will be able to, carbon credits are created by these solar and wind. Okay, they make this transaction happen. Carbon credits are sold under smart contracts to the people who are planning to buy. Okay, they are measuring this carbon emission, and through another blockchain enabled carbon trading, these funds are transferred using smart contracts. So selling time and buying time, there are smart contracts, and we definitely know the significance of doing a particular transaction through blockchain. So this is common, this algorithm if I say, or a cycle which I say, is common for REC trading and also carbon emission, carbon credits and emission trading also. Right. A very, very important aspect, two important aspects which we will be spending more time as an application. One is SCADA, supervisory control and data acquisition. Two is on electrical vehicles. So one by one we will take them up. And I always have been telling you, I have been informed that cyber security is 100% an automated thing which has to be taken care of. Okay, and in that very big application itself, blockchain plays a major role. So supervisory control data acquisition can be for any automation system, industrial automation, pipeline, any industrial control systems. So we will definitely talk about power SCADA, very important aspect of that. As I was telling you, the architecture of a smart grid, you have your physical devices, generation, transmission and distribution sector, physical devices. All these physical devices have sensors on them which are measuring voltage, current, and from there lot of new data gets generated. That data helps to understand the health of your electrical system, the frequency, the voltage, the current, the phase angle. There are many, many parameters to it. So all those things are determined. And all these sensors that are placed, they communicate this data to a center called as supervisory control and data acquisition. This is the brain of healthy operation of your electrical grid. At this location, this is centralized in this example. Now there are also decentralized examples also, where at substation level itself some intelligence is put. But this is an example where the entire data is sent to a SCADA control center. All the key decisions are taken there. The high-end algorithms, predictive things are all done there. If you are forecasting a possible brownout or a blackout, people don't reach there. Before that, corrective measures are taken. Systems are tried, and at the best, self-healing is ensured. All these things are there. So this is the intelligence, this is the brain of your electrical system. Okay, but to ensure that this brain gets the right data signal, all these things have to have a proper security of data transfer. This is how a SCADA center would look like. These are all the single line diagrams of your electrical grid, which some of you wouldn't understand. There is people sitting there continuously taking decisions, getting data from different substations. How is the voltage? How is the transmission line loading? How is the distribution line loading, feeder loading? Is the transaction happening in the way it was scheduled to happen? Contingencies are taken care, and there are many, many electrical aspects that are continuously monitored 24/7. Okay, and accordingly decisions are taken to ensure that system is healthy. If there arise a need, they may do load shedding. Okay, if there is excess of less generation and more demand, then maybe they will do load shedding. They may change the transformer settings. There are so many electrical appliances, electrical components which help us maintain the health of the system. So all those decisions are taken provided the data is coming to this place in the correct exact form. Okay, so that is the significance of this SCADA. And please understand that worldwide there are many hackers who are behind any country's SCADA, because if they disrupt a SCADA system, the data going into a SCADA system, manipulate the data or disrupt it or take control of it, then they will be able to directly hit the country's reputation, economy, per capita and other things. So therefore, this is just a few attacks. There are umpty number of attacks happening. Definitely some countries or every attack is not informed, because it is not, it's understood why it is not informed. So these are some of the world popular attacks, and many more are also there. Okay, Stuxnet attack, this is one attack which shook the world, right? And this is done on an Iranian uranium enrichment plant, Natanz. There is a black energy kind of an attack done 2014 Russia. Black energy 3 is also there. Okay, then there is a phantom mouse attack, which was, these are very specific to electrical system attacks. Non-electric are also there. Gas stations, oil transportation attacks are there. So there are attacks on many different things, but specific to electrical, I am giving you this information on the Ukraine phantom mouse attack, where someone has taken a complete control of the SCADA system, and remotely they have accessed, made a mimic of that SCADA system, and on the day when they wanted to plan the attack, they have ensured that the actual authorized people of taking control of the system, changing the settings of different electrical appliances, those people are, they were removed from the access. They were unable to access those electrical components, and the people who have hacked the system, they took control. Okay, literally they were not able to do anything. The authorized people in the substations or the control centers, they took control, and they have opened so many circuit breakers, and they have made a huge issue out of that. It took hours for people to come back, restore back the system. So this is the capacity of attacking or playing with the SCADA system. Okay, Stuxnet is quite popular. Okay, black energy and such things, and there are continuous attacks happening on many countries. These are just a few. Okay, and this is in 1982. So this is some pipelines and other things. These are all there. Okay. One of the initial attacks on US was on Salt River project. Again, it's a power and utility attack on the power system only. There are some attacks on the waste water management, some attacks on the petroleum, nuclear power plant. Also, there were some attacks. See, these are all continuously these are all SCADA systems, by the way, supervisory control systems which take control of a big entities. So when such things are there, there's a lot of data transfer. Blockchain would come into picture so that every data transferred is well monitored, ensured. The transparency of the data is also there, safety, security is also maintained. So this is a flow of that. You have at your physical layer, you have your transmission, consumption, distribution, all these things. Okay, and then all this data is, you can send them, they can be sent through sensor on the blockchain, so that all these data are kept secured. And from here, this generation data, there is a information and communication layer, ICT layer, where data flow is there. In this layer, you have at the transmission level, a lot of balancing mechanism happens, power balance happens. At the distribution level, you have demand side management, smart meter management, real-time monitoring. These are all the different functions that happen. Data is exchanged and decisions are made. All this data is also passed through a blockchain so that this information is taken care. At market level also, there is a lot of, every entity transacts with every other entity. So this transaction, if you take a market layer, here you will be deciding, the trading happens, bidding happens, tariff offerings happen, and all those things. These things also can be put on a blockchain. So at every stage, I would say, you can have blockchain simply because you have data that is getting transferred. The data, very, very precious. Very, very, very precious. Not just normal, any data. Very precious data, whose tampering would affect greatly. So we will be able to very conveniently take it. Only thing here is that one note is, these things should happen very fast. Electrical systems, we detect in cycles of 2.5 cycles. Sometimes you have to take an action. Cycles means one cycle is 20 milliseconds. So 2.5 cycles means, just you have to imagine. Some decisions are taken at that fast rate. So latency needs to be minimized. That way, you have to ensure that your blockchain consensus are done, right? Electrical vehicles, again, this is a very important area where blockchain can play a good amount of role. In power trading, in our country, we are using blockchain, but EV, we don't have so many electrical vehicles on the road, particularly automated in nature. So therefore, presently in our country, these are all the futuristic issues that we need to handle. We have to be prepared to ensure that we don't get into that trap. If you just see an EV, a plug-in electric vehicle, there are many kinds of electrical vehicles. Purely battery operated electrical vehicle. Reva was one example, 20-25 years back. I don't know how many of you have seen Reva. This was Mahindra's thing. So it is a small car, it can't take too much of load also. 2 passengers can sit comfortably with a bit of luggage. Reva has an extension also, but that was a purely battery operated electrical vehicle. After that, we had a hybrid electrical vehicle where you had battery also, you have fuel tank also. Okay, hybrid, battery and fuel tank. And now today, we talk about plug-in hybrid electrical vehicle. The battery that you are having in your car, in your two-wheeler, four-wheeler, you will be able to recharge it. This is a rechargeable battery. Just like you recharge your phone battery, you recharge your many other things, you are also able to recharge your car, two-wheeler, transportation's battery. So this is plug-in hybrid because battery is there, fuel is there. You can plug in and recharge it. Therefore, plug-in hybrid electrical, this is the thing of the day. Okay. When you talk about such a thing, there are so many components in it. You have your, you also operate on fuel, you have your internal combustion engine, lot of power electronic controllers, okay, these are thermal systems, lot of heat dissipation which needs to be well managed. This entire bed, the bottom part is your battery pack, okay, and then in this, you have all these components in these electrical vehicle or PHEV, plug-in hybrid electric vehicle, they talk to each other, not the way we talk. They talk, they communicate each other. There is typically a protocol that is used, which is CAN bus protocol, okay, typically used in your car, to interface or communicate between the different segments. What communication do? They do many. I will give an example of few. When I am going on a long ride, I need to have a clear picture of how much of my battery charging is there, how much is my fuel tank filled. Normally, I fill it full when I am planning a long drive, highway drive or whatsoever it is. So I have ensured that my fuel tank is full, my battery pack is full, and then initially I may want to exhaust my battery to up to 20%, 100% charged battery I start, I may want to exhaust it to 20 or 30%. It's up to the person who is using it. And once it is 20 or 30%, after that discharging the battery is not recommended. So I'm restricting myself to 20%. After that, I want to shift to fuel so that till at least I get the nearest electrical vehicle charging station. Okay. Then when I reach to an electrical vehicle charging station, I would like to recharge my battery to its full capacity. I may have to wait for some time. It's a time thing in the side is there. It's not like petrol, in 5 minutes you are filling, refueling and leaving. It's not so. It takes some time. So the point I'm trying to say is that I need to have an exact understanding of how much battery has got discharged. What is exactly the way you understand your phone's battery. It's the 20%, 15%, then you search for recharging it, you know. So this is what happens for even a car. And then internally, there is a lot of thermal management. Okay, heat has to get dissipated, otherwise the battery efficiency depends upon the heat, the way it is handled. Thermal management is very, very important when you are operating it. There are some temperatures below which inefficiency occurs, above which also inefficiency of the battery occurs. This has to be well maintained. And there are auxiliary devices, AC, child locks, security things. So all these, they communicate with each other through a protocol called as one of the key protocols, one of the mostly used protocols is CAN bus protocol. I am a hacker. The system is an automated machine with little human intervention only. At least these protocols can be hacked. And they do happen. It's not like we are talking about a fictitious case. Many people, there are many videos available. Tesla, you take Jeep Compass. They have tested these things on their EVs, automated EVs. And many things are available on the open forum wherein they tested. There were competitions held by them. Kaspersky also does, many other people also do, where they are inviting people to hack their systems, and when they are able to successfully do it, they know where is my lacuna, they are rectifying it and also paying for to the hacker. So these kind of things are very well known. So I am just trying to say that this electrical vehicle, this automated one, if someone is hacking the data, what they can do. I am of the assumption that my battery is 50% only discharged, my fuel tank is full. Someone hacked my system and the battery has come down to 20% and even coming down further. And he has hacked such a way that it's shifting to the petrol mode or the fuel mode. So what happens suddenly? Your battery is deteriorating fast. That is one side of it. Other side of it is you're not switching to an alternate drive. And there is a wear and tear. Or if I first choose to finish my fuel, I finished my fuel and I'm not getting an alert that fuel is completing or my battery is also discharging. All these things would lead to somewhere in the middle of a highway, not at all close to any recharging station. You are held up in the middle of the way. If it is daytime, this is one problem. If it is in night time, there is another problem. If your GPS is hacked, if your steering is hacked, all these things, please understand, they are not fictitious. They are happening. There is a possibility for them to happen. Okay? So all these things, if they are done, it will lead into huge chaos, sometimes fatal as well. So these are all the different threats that can happen. You have all these things in your car. Okay, there are a lot of sensors which can be attacked. These are all the areas where attacks can happen. EV battery attacks can happen. This thing, CAN bus attacks, of course, that is how. Then you have many others also there, media attacks. You can have a ransomware file, and third party are there, spamming, advertising. Now, the more and more sophisticated your vehicle, automated the vehicle, the higher the possibility. So these are, and even there is a lot of issues when we to the charging infrastructure, charging stations, electrical vehicle, EV, electric vehicles charging stations. So these are all the places where attacks are possible. So we need to be very, careful. So these are all the possible places. This is a complete battery pack. They can the state of the charge of the battery, which is the percentage discharge or percentage of charge available. Okay, and even when you're charging it at this location, also there are lot of vulnerabilities that can happen. Okay, vehicle to vehicle, it's not just the electrical vehicle connecting itself to the grid. Electrical vehicle can connect itself to grid, which is called vehicle to grid technology. Electrical vehicle can connect to another electrical vehicle, make a transaction happen. V to V, vehicle to vehicle transaction. Vehicle to home, V to H. Vehicle to load, V to L. So many and it also takes power from the grid, so grid to vehicle. These are called V to X technologies. Everywhere you have a transaction of power flow. Okay? Everywhere there's a data flow, you have unique ID, you are also going to pay. I'm not going to give free of cost. So I also have to pay for it. All these things, there's a lot of data transfer, energy, power transfer, all needs to be recorded. Everything can go on blockchain so that things are authentic and there is no issue with that transaction. These are some of the kinds of threats. Access to start stop of the car can happen, steering, all these possibilities are there, well demonstrated also. These fundamentally there is a communication happening and which has to be protected, which can be done through a blockchain application as an application. So your vehicles as prosumers, everything, your transaction, if it is done vehicle to anything, you run it through your blockchain so that you all know that blockchain has a set of things. Just like that, I cannot change the data. I cannot change it. There are people who need to approve it also. So this would ensure that 4 or 5 people, good number of people, all the authorized people are involved in it for making any change or any such thing. So this is automatically making it protected also, secure also. So electrical vehicle charging stations, when I just talk about an EV, this is next few 5 slides are from India has a very well documented thing. Niti Aayog is one of the leading people who are doing it, and also some of our IITs are also supporting them in making this document. When you are running your electrical vehicle on the road, there are so many stakeholders that come into picture. The stakeholders, original equipment manufacturer of your car or two-wheeler, the charging point operator, infrastructure provider, the connectors, the protocols, the distributor, the retailers, the transmission system operators, fleet aggregators, regulatory bodies, cyber security. These are all the people, these are all the things, stakeholders which come into picture. Each one has a role to play. Each one needs to talk to each other to make some important aspects happen. So we need to ensure that all of them are taken care. If you have to charge your electrical vehicle, there are many ways you can charge them. So everything, there's a data flow, and there is also, because payments have to be made, nothing is for free. And secondly, there is energy flow anyway. You can have AC charging, you can have DC charging. Type 1 is a charging that you do at your home. Domestic charging is type 1. Type 2 and type 3 DC are also there. Okay, so public charging is there. There also we need to be careful. Battery swapping is also one possibility, because there is not much, if you don't have much time, there are also battery swapping stations. You take your old battery, your existing car battery which has discharged, give it to a battery charging station and take fully charged battery. It has its pros and cons, but still battery swapping is also one of the methods. Everywhere there is a transaction happening, because financial aspects are involved. So these are the different levels of charging. Okay, these are the connectors. If you only one student is using the connectors, DC connector, AC connector. Many countries have designed. India is also designing its connector. Okay, there is a lot of communication protocols between electrical vehicle charging station to a central entity. Okay, distribution system operator, clearinghouse, everyone, there is a way you communicate. When I say there are protocols for communication, if I hack, I can ensure that you are getting a wrong data which you are reading. Though the other one is sending the right data in between. Many kinds of attacks are there. Man in the middle attack. So many attacks are there. So these attacks should not affect your data's sanctity. Fleet aggregators, these are another stakeholders. Okay, these are all the people. They need to be communicated, come to this location in this time, stuff like that. You have a lot of certifications also which need to be done when you are talking about ensuring. You cannot just retrofit your two-wheeler or buy a new or launch a electrical vehicle. There are some tests that need to be done. These are the agencies that do. And on my own, I should not paste the sticker. ARAI, if you have, mostly you told, na? You have a sticker, ARAI sticker, mostly. So that says that this is in compliance with the requirements of ensuring that it is a electrical vehicle thing. So like that, there are many people which do it. She should not paste that sticker. It should be coming from. So to ensure that, there should be a mechanism, and this very application helps. Lot of tests are there, crash test is there, lot of things. All these things have to be, so in this process, you have lot of transactions happening, and it has to happen through a blockchain. Battery swapping, this is one example. In this example, you will be able to see that your battery is fully discharged. You are going to a battery swapping station, okay? And this battery swapping station has lot of fully charged batteries, which have to be put into your car, and there is a power trading happening with the microgrid. These batteries were charged from a microgrid. Utility grid also, through utility grid, the battery would have been charged. Through a microgrid, battery would have been charged. So there is a financial side to it, and at the end of the day, you are only dealing with the station. So this is also a transaction. All these things can happen over blockchain. Okay. I was discussing the various vehicle to grid technologies. In each of this, exchange of power, exchange of data, exchange of money, you should have a body which will take care. I should not be waiting for him to pay me, because everything is time, is money, which is, if you are getting 1 rupee today, 100 rupee today, 100 rupee 1 month from now, there is an interest component that gets added up. Okay, and many things are there. You can avoid lot of billing issues, you can avoid lot of payment issues. Everything gets automated through this. So it has a lot, and no one can touch it. No one can change your bill. Okay, hopefully it's correctly generated. I'm talking about that. So these are all the different technologies which an electrical vehicle deals with. Every transaction happening, you can put them on the blockchain. Another very important application is microgrids. Now, what are microgrids? All this time, we're talking about smart grids, smart power grids, this grid, that grid. What is microgrid? Will it be seen by naked eye if it's at micro level? Of course, it can be seen. Microgrids, your laptop is called a picogrid. As an example for you to understand, it's called picogrid. If I can make you understand how. Once I fully charge my battery, I can remove this connection point. The connection point is the power that the laptop takes from the grid. This is the grid. I'll explain what is microgrid. This is your grid, because it's the Goa Electricity Department which is providing the grid. This is your picogrid, microgrid. Microgrid, nanogrid, picogrid, these are some words depending upon what is the power level handled by that. The small power level, so it's a pico, in much lesser than that. If I remove this also, the connection with the grid, my battery is still, my laptop is still operating. I call it as a smaller grid because there is generation happening, consumption happening, right? Because I am consuming power, I am able to show you an output over here, right? There is generation as such not happening in that way, but the battery being completely charged, now it is the source of energy. So you have a source, you have a load, you have all the operations getting done, okay? And the grid is removed. This is the grid that is getting removed. So a microgrid, this is a small example of one load, this laptop. A microgrid is a bigger size in few megawatts or kilowatts, not megawatts, kilowatts, it could be megawatt also level, wherein you have your own in-house generation or a source of power, generating power. You have a consumption also, you consume it also for different applications, domestic application, agricultural application, commercial application, or in an industrial application. So you have a source of generation, you have a load also in it. This a boundary if you draw, you can connect this microgrid, this becomes a microgrid. It can get connected to the main grid, grid connected microgrid it is called, or you can also operate it without being grid connected. It's called an islanded microgrid, okay, standalone microgrid. Most these microgrids are very much present in our country. If you take the northeastern plain, northeastern states of our country, to lay a transmission line from the mainland to a hilltop, there's a lot of investment. If there is a lot of cyclonic or any such landslides or such things, these infrastructures get affected. So people are preferring to operate on a microgrid, standalone microgrids. That means they run their rooftop solar, they run their machines, whatever they have equipment, whether it is appliance wise or if it's a small industrial setup, they do it, and they are not connected to the grid. They run independently, okay? With rooftop solar installation, they are charging their battery requirement, because rooftop solar, or it is only in the daytime, sun is there, and after that you have to have a storage mechanism which you will be using it in the after hours. Wind based also, wind is 24/7, but wind blow should be good enough, wind speed should be good enough. I'm just trying to say this is called as a microgrid setup, which is a smaller grid which can operate connected with the main grid, or it can operate in the standalone mode also, okay? Now microgrid, nanogrid, picogrid, these are the presently 3 words that I am aware, in addition to the main big power system grid, electrical grid. Their micro, nano, pico is a word which reflects the amount of the load, how much load is available, okay? In this, there are solar plants, there are electrical vehicles, there are buildings and businesses that run. You have energy storage 100% required for a microgrid to run if it is not grid connected in nature. And you have, okay, all these things, all of them, they interact with your smart homes, smart buildings, okay? Each of them have to transact with each other, and they buy power, sell power through smart contracts, and there is a complete system can be put on blockchain, and everything can be run through a blockchain mode to ensure that all the transactions are secure, and payment clearances and all these things also don't have any issue. Not only that, you can also do a bilateral transaction. I am a microgrid operator. I have 3-4 options. I am a distribution company, means I need power. I don't generate power, I need power. And I have 3-4 options of people who generate power. Based upon the cost at which you are selling, I can change. This half day I will take from one particular generating power source, some other day depending upon whoever is giving me good quality power at a decent cost, low cost rather, I will be preferring that person. Quality, reliability of supply along with the cost of units. All the three are important. If I sell cheap power for a lower cost, but my reliability and quality is not good. Quality of power means it is, again, power quality is a big topic. The voltage, you should not have dim lighting. Okay, if to make you understand in simple words, flickers should not happen. Just because I turn on my geyser, it should not flicker. If it is flickering, the power quality is not good. It's an indication to that. Voltage should not get dimmed off. Or at the night time, you see over voltages. These are all power quality issues. Okay, so I will prefer to take power from a person who gives me power, good quality, reliable. There should not be too many turning offs, okay, load sheddings. So therefore, good quality, reliable, and at a decent cost. Decent, when I say, I mean the least cost only. So when these transactions happen, when I have an option to take from one of you, and everything should be automated and all, blockchain has a very important role to play. And not only that, I should not be paying bill of my neighbor. Correct? No. So therefore, I also my transaction should be secure also. Someone should not consuming and bill is coming on my name. That should also not happen. So security of the transaction also plays a role. All these things are definitely possible with a blockchain in place. So we are almost like concluding things. You have lot of energy meters. You have microgrids. Here the example talks about 3 microgrids. Microgrid 1, okay, it has got smart meter aggregator, wind farm aggregator, solar aggregator, energy storage aggregator. When I say energy meter, it means the load, which is measuring the data, the power that is drawn. Wind, solar, and storage, these are other important things in a microgrid. So these people are transacting with each other. All these transactions can be recorded through a blockchain. In addition to them, will not be detailing that wind forecasting. So why I am very specific to wind and solar is because these are intermittent sources. They are not predictable. So when they're not so predictable, they are fluctuating in nature, it becomes very important to have a good forecasting system in place to the best possibility. So therefore, in this also blockchain is there. A lot of sensor data comes into picture, and lot of applications are there, tools are there to ensure that you are near accurate. So a lot of trading also happens. In this trading process, you have blockchain. This is one example. Renewable energy trading, which is also selling the energy that you have produced. So I will close it with this, more or less the final thing. In energy management, this is, you can say holistically the final slide. In energy management, you have many entities. You have your generating stations, transmission networks, you have your distribution systems, electrical vehicles, renewable sources, lot of devices in your system, all of them sharing lot of data, extremely costly equipment. They are not, again, something you can lose. No, they can't. So all of these things, generating data, exchanging data, information, money, all of them, when they are placed on a blockchain, they ensure privacy of data, security of data, cyber security aspects are covered. There are a lot of advantages. Electrical application is one of the important applications where blockchain plays a good role, right? So definitely there are, every technology has challenges which needs to be addressed, and electricity is something where decisions have to be taken at a faster rate because it affects someone staying, you know. So therefore the challenges is scalability. When your volume of data is increasing, getting consensus at a good rate, latency should be reduced. So that is one challenge which has to be addressed. It's already addressed, but it's a process. Regulatory government frameworks also will will need to be in line with your requirement. Energy consumption, mining, and then you have to adopt to all the barriers. All these things you have to handle some of the challenges. So conclusion is, these are the advantages of blockchain, which are also the conclusion. So you can run your system with low cost, higher efficiency, definitely enhanced security. You're assured of your security, sustainability also, because if you're secure, you're sustainable eventually. These are some of the references. Most of the references are put. Some references I've taken from Google photographs, so I couldn't get the original source files. So these are some journal papers and websites through which, thank you. You can go for some questions if you want.